Okay, so today we'll be going over CSM's week 8 worksheet, namely problem 3 on linked lists. And this problem is actually preceded by problem 2, so we'll go over that first, or just read the problem statement really quickly. So in problem 2, we were supposed to write a function skip, which takes in a link and returns a new link with every other element skipped. So for example, if we pass in a linked list A, which is equal to 1, 2, 3, 4 into skip, our skip function should return a linked list that skips over the elements 2 and 4. So that is, it returns a linked list with elements 1 and 3. And there should be another video. We're not going to go over that problem in this video, but there should be another video made by another mentor that goes over that. But instead, let's see how problem 3 differs. So in problem 3, instead of returning a new list, we are mutating the original list. So in order to avoid returning any new list or making a new list altogether, we're not going to call the link constructor. That is all the guidance we have been given. We also have this doc test, which might be useful to go over that. So in this doc test, we are given 8, which equals the linked list, which equals 1, pointing to 2, pointing to 3, and then pointing to 4. Can I squeeze it in? Yes, I can. Now, when we call skip on this linked list, we end up with 1 pointing to 3. So the 2 and the 4 have kind of just disappeared. Now let's try to think about how we might, I guess, go about obtaining this 1, 3 form from this 1, 2, 3, 4 form using pointer manipulation. So in order to get to this 1, 3 form, we would actually want to modify this pointer here, which comes after the 1. So I should probably use the eraser. We want to erase this pointer and instead redirect it to 3. Now, assuming we have our list variable pointing to 1, in code, this would look like this. We would be taking list.rest and setting it equal to the 3, 4, which is list.rest.rest. Okay, so we have that part done. Now, of course, there are a few problems with this, and I encourage you to think about that in the meantime until we come to it. But we've, I guess, for now, taken care of skipping over the 2. We still have to skip over the 4, though, so we haven't gotten over that. But notice how, based off of our definition of the skip function, if we were to call skip on the linked list with 3 as its first entry and 4 as its second entry, skip should modify that linked list to get rid of the 4. So why don't we go ahead and, assuming our skip function works, which so far it doesn't, but assuming it works, this is, I guess, a recursive leap of faith, let's go ahead and call skip on 3, 4. So what is 3, 4 in the context of list? Since we've actually set list.rest at point to this 3, 4, so we'll just call skip on list.rest. Okay, so now we've skipped over the 2, and 2, we've also skipped over the 4, so that now we should have this. You might be thinking something's missing, and if you were thinking that our base cases are missing, you would be right. So let's think about how we can construct our base cases. Now, back to those problems I mentioned earlier. This statement over here in line 3 assumes, 1, that list has a .rest, and 2, that list has a .rest.rest. So that's a pretty brave assumption, I would say. So let's try to construct our base cases to make these assumptions valid. That is, we want to construct our base cases such that if those conditions aren't satisfied, that is, if we don't have a .rest, and of course a .rest, then we shouldn't execute these 2 lines. So if we think about when we might have a when we might not have a dot rest, that is when our list equals link.empty. So if our list is link.empty, we don't have a dot rest, much less a dot rest, and we want to, I guess, do nothing. I'll just leave that as a placeholder for now. So, but if we get past this base case, we know that we have a list.rest. We don't necessarily know that we have a list.rest though, but we can have this other base case, which is else if list.rest, which we know exists, is link.empty. And if list.rest is link.empty, we know there is no list.rest, so we again want to, I guess, do nothing. And we'll talk about that again later. Now notice how these, and of course, if we pass this base case, we know that we have both a list.rest and a list.rest. So lines 6 and 7 should run smoothly. Now notice how if either of these two base cases are satisfied, we do the same thing. That is to say, we do nothing. So why don't we go ahead and combine them into one base case? And the way in which we would connect them is through an or, because we want to do nothing if one or the other is satisfied. So if list is link.empty, or if list.rest is link.empty, we want to do nothing. And I'll go ahead and get rid of this. Okay. Now, how exactly might we do nothing? There are a few ways to go about doing this. One is we might just call return. I know we don't want to return anything, but if we call return followed by nothing, then our function will just terminate. So that's the useful thing about Python if you did not already know. But if you did not know that, then I'll again put that placeholder do nothing there for now. And we could instead put our lines 4 and 5. We can instead have them nested within this else statement. So they are only satisfied if this first base case is false. And I suppose you'd have to put something here to replace the do nothing. And another way you could do this is we could just forget our base case altogether and only execute lines 5 and 6 if the negation of our base case is true. So if I guess list is not link.empty and list.rest is not link.empty. So yeah, either of those three things should work. And as a sanity check, let's just run through our example one more time. Let's see if we missed anything. So our list is equal to 1, 2, 3, 4. When we call skip on it, we want to mutate it so that it equals 1, 3. So if list is not link.empty, which we know it isn't, and if list.rest is not link.empty, which we know it isn't, we want to execute these two lines. A quick note though about this base case. The order of these two statements on either side of the and does matter, because on this side, we assume that there is a list.rest, but we can only make that assumption because we've passed this first base case, where list that tells us that list is not link.empty. Okay, but yeah, if these two things, we know we've passed the statement, so we can go ahead and execute lines 3 and 4. So we're going to reassign list.rest to list.rest.rest. So we successfully skipped over 2. And now we're going to call skip on list.rest. And I'll draw out this second subcall, hopefully to make it a bit easier to digest. So right now we're calling, there we go. We're calling skip on 3, 4. Okay, so let's look at our base case again. List is not link.empty, we know that, so we satisfy the first part of our base case. List.rest is 4. So list.rest is not link.empty either. So in that case, we can go ahead and execute lines 3 and 4. we're going to set list.rest, which is this thing right over here. We're going to set that equal to list.rest.rest. Whoops. Let's use red for this. Sorry, technical difficulties. I guess we won't use red. We're going to set this pointer equal to whatever the pointer of 4 is pointing to. In this case, it's just pointing to link.empty. So instead of, honestly, we don't even have to do this. Instead, we could just replace 3's pointer with what we usually use to denote link.empty, which is a cross here. And then if we were to call skip on list.rest, well, right now, because of that first operation in line 3, list.rest equals link.empty. So let's go ahead and see what skip looks like when it's called on link.empty. Okay, so if list is not link.empty, well, right away we see that we've actually filled this base case. So we're going to skip over lines 3 and 4. At that point, we don't really have anything left in our function, so we do nothing. And if we backtrack a bit, you'll see that in our first call, we skipped over the 2. In our second call, we skipped over the 4. And at that point, we don't really have anything left to do. So, which is what we ended up doing. That is nothing. So let's verify that this actually works for our doc test. I'll go ahead and copy and paste this so I don't have to count the parentheses. So we have our A. When we call skip on A, or just to verify, this is about A equals. So when we call skip on A, and we call A again, we get what we are expecting, link 1, 3.